Hello everyone, my name is Ayush Singh and today I will be sharing my work on this Strava fitness project. So this is the overview of our project or basically the outline. We will first go through the problem statement, then data exploration and initial pre-processing, visuals and insights. The final insights or suggestions we will be giving to the Bella marketing team and our future works. So let's start. So our business objective is to understand that how the consumers are using the smart devices. Okay, so basically we have Bella built a small company. So basically it is all successful and it is related to a health industry. So basically they manufacture smart devices to track health parameters like calories, activities, their sleeping patterns, uh, their number of steps they take on a day-to-day basis. So and we have Sarsan. She basically the founding member of the Bellable team, and she understands that we can use the consumer data to gain more insights, which will be helpful for the Bellable team. So our task here is to analyze one of these smart devices data to gain the insights on that how customers are using these devices, and after gaining these insights, we have to share them to the Bellable executive team and the to the Bellabel's marketing strategy team. So let's have a quick overview of the type of data we have here. So we have calories dataset, sleep, intensities, steps, activity, weight, heart rate, METs. So for activity, weight, heart rate, and METs, we have only single CSV files. MET have a daily record. Weight was it was not related to time. Okay, and the heart rate we have down to seconds, the METs were down to minutes, calories we have daily records hourly and up to the minutes, for sleep we have daily and up to the minutes, the for intensity and steps we have daily, hourly and two datasets for the minutes. For two datasets for the minutes, basically we have a kind of narrow and wide, we will see it. So okay, so we have total 18 CSV files. We will try to explore these files and do some initial pre-processing. So the first dataset we picked was based on activity. So we have ID, activity date, total steps taken, total distance, tracker distance, and this was the very some labels: very active distance or moderately active distance, light active distance or sedentary active distance. Same was for the minutes: very active, fairly, lightly, and sedentary minutes. Okay, so then we went to like for describing the features to get the mean, standard, minimum, and the quartiles. Okay, so these were also the null values we have and the data type and the memory uses. So after that we found that the differences between total distance and tracker distance was almost minimum. They were quite close. The numbers were quite similar, so I wanted to understand that are they 100% same or there is some kind of difference. So basically we plotted a graph and we found that for few values there were some differences, and I wanted to check like mathematically like 97% or 95% or 100%, like what was the numerical matching percentage. So we found that around 98% was a match and 1.6% was quite a difference. So basically we just dropped this column. So basically, and also this won't be an important feature for understanding uh, or doing or further data analysis process. So here we look for the residuals greater than 0. So the residual is basically the difference between these two. Okay. So after that we were also trying to combine the two features. So let's say we have moderately and light active distance. We combined them to the medium active distance, and we same did for the minutes. So this was just uh, to done to ease our data analysis in the downstream. So we dropped the columns, tracker distance, and the same four, like we already used them to make a new feature, and the log derivative distance was almost zero for all the features. So we already saved this file. And we did the same, almost same for the weights. Here we see that the weight pounds is just a factor of kg. We just dropped it, and the fat was almost zero except for 2 3 rows. And the log ID and each manual report was not a necessary feature for us. Really, this was the part we were doing. We were looking for the features which were important or not, and we were dropping it, and we were just saving the some kind of filtered data frame or filtered data set, which will be helpful for us to perform the data analysis and the downstream tasks. Okay, then we went for heart rate. It was measured up to the seconds. Okay, heart rate was up to the, okay, great, every 5 seconds. Okay, I've also looked at how many users have given their contributed to today's data set. We have 40 users on describe, and we just simply saved it. There was nothing to change. Okay, same was for MATs. They went for sleep. We sleep, when sleep we had 12 sleep records, total minutes asleep and total time in bed. We didn't change much, we just simply saved it. Sleep, we for sleep we have two kind of data set. One was on a day-to-day basis, daily, and for other was for the minutes. We removed the log ID here because we won't be using it. After dropping the log ID, we saved it. We went for calories. Calories, we also have multiple data set. This was daily basis. This looks good. We will just save it simply. Then we for hourly. This also looks fine. And after we went, then we went to seconds. Just confirm we have second. Okay, this is what we're talking about. We have two kind of data set. Sorry, we don't have seconds. We have daily, hourly, and minutes. For minutes, we had two kind of data set, narrow and wide. So we wanted to confirm that both were actually the same data set or different. So after checking, there was 98% overlap. It was exactly the same. Just to show you the data set, there was a slight difference. Like this was a wide one. So here basically for each minute we have expanded as a column. Like we can see there's 59 calories, 59, and calories 00 started around there are 60 columns. So basically for each minute we have stored, and here we have separate rows for each minute. So I have proved also. Basically I have picked a specific column row, you can say. So if we look at the values 1.8876, 1.76, 2.2022, 0.94, 0.94. These are almost overlap. The initial I have to go uh, down to 1440 because the starting time was different. Around a day or some few hours there was difference. So that's why I did some shifting. And after that there was exact overlap, almost exact. I already looked over that. It was around 98% overlap. Great. So okay, then basically we dropped the wider one. We only processed one of them, and we simply saved it later on. Let's move to intensity. It was also similar. We have daily, and with the same kind of processing, we created new features like we merged slightly and fairly into medium, and we have sedentary and active. So basically, we converted these four labels into three: very active as one, sedentary as one, and lightly and fairly combined into one. The same went for these two: sedentary as one, very active as one, and we combined these two as a single one. This was the same kind of processing we did previously for activity, and this is intensity. So there was no specific reason to pick this. We basically, I wanted to reduce the number of labels we have and to ease our calculation for in further steps. And it actually it won't get much of a difference to us that user have spent a little bit more time in fairly or a little bit more time in lightly, because we just want to gain an overall understanding. Then we have hourly data set, and then same was for the minutes. We also compared to data set. There was a match, and we just dropped one of them later on. Then move through the steps. We have daily data set. Okay, this looks good. We then just simply copied it and saved it. We have hourly. This also looks great. And we have minutes. The same way, minutes, narrow and the wide. Okay, great. There also good amount of overlap, and we'll drop in one of them. Okay, so let's have a quick overview of visualization and final insights. I will speed up the process because I'm taking too much time to explain. Okay, let's move to the activity. We loaded our pre-processed file. This was very messy plot. I just wanted to see like how the graph will look like. I didn't change it because I wanted to keep it so that in future I will look back. So then later I went for average. We use group by. So this was the average total steps over time for all users. Let's say on this date, what is the average step taken by all the users? Okay, so this was the plot. We were finding some drop in the last week. Okay, so this was the total distance over time for all users. So this was total steps. Okay, we confirm. Okay, so now when to observe evaluation by activity type over time. Okay, so basically this was uh, one was very active, yellow one. So yellow is medium is very high, and then very active, and then sedentary. This was basically the distribution between these three levels, active as distance, and we also have for the time, sedentary minutes, and very active minutes, and medium minutes. Then we went to visualize the weight portion. Weight was very important for us because weight is an kind of we can say an attractive parameter for the user because they actually many of them most of the people want to reduce their weight, and the number of unique users we have 8 for this. Okay, we wanted to calculate the weight change for each users. So the percent of users whose weight decreased were around 50%. Out of the 8, 4%, 4 people actually shows decrease in the weight. Okay, we also wanted to understand that what is the maximum decrease in weight we saw. So basically one of the users reduced his weight by 1.8 kg. So this might not seem a good number because we only have a dataset for a single month. If we had dataset for around three months or 6 months, we might see some more extreme results like extreme changes in weight. Okay, so an average weight decrease per user was around 0.7 kg. This looks good. Every user who has used it has reduced his weight. Okay, on average. And you also want to see that has anyone changed his like BMI, let's say from overweight to fit. No, but we don't find any such information. Like no, there was no such user basically. We tried to like make some plots. So here you won't see much of difference because it was only a month of data set. So okay, so let me move for the bar chart. Start with the end and the BMI per user. Okay, so similarly, not a much of change as I informed. Like this is only a month of data set. Because also uh, the data was provided to us like for one user we have a single data point, for few we have up to this range of, we can see the weight was not varying much. This was almost which we could think of previously only because in month we can't see a massive improvement in one weight. The changing health and weight, it's a cumulative effort, like it take time. Initially 1 month to 2 month, there's not much of a factor. So we have only one data set, so we can't get more insights. Found that one of the users lost 1.78 kgs. Great. We have heart rate. Want to understand the minimum max value of the heart rate we got. So for each user, so this was the minimum max heart rate for each of the users. Okay, so basically we plotted also for the same data frame we got previously, and we also plotted the heart rate variation over time for 14 users. This is quite messy. This I just wanted to plot it. I didn't use it for the insights. Okay, and this is next we want to amities. So amities was a new important concept, so I just kept a description about it. Basically, amities is the number which indicates that relative rate at which you burn calories during an activity. So if an activity is 4, it means that it requires 4 times energy than it is required by sitting still. And then also a good example. For example, let's say a person sitting quietly represents 1 METs, whereas jogging 6 miles per hour represents 10 METs. And multiplying the MET by the minutes, we get an MET in minutes. And healthy adults should expand this much METs to day-to-day life. Okay, so basically it's kind of total energy we need to spend per day to have a healthy life or a healthy body. This was total METs spent by our users. We also want to understand like on day 1, day 15 and last day. So basically did the amount of energy spent by the users increase, or what was the change, like what was the pattern in that. So basically I plotted day 1, day 15 and last day. So this was the relation. Last day was basically last week saw some decline, so this we can't rely on this much. Okay, so, and the average daily energy across all users, we can see that you will see all the plots there is a decline in the last week. But average energy speed per day all by all users is around 20 MET minutes. So we have also created a heat map for that. Now comes our sleep. This was the question I was trying to answer, like how much sleeping pattern changed in this period for each hour. I'm looking for how many users have increased their sleeping hours. Okay, and in the form of numerical values, and also the plot. So around 25% of our users have shown improvement. That's a good sign, because sleeping pattern could be a very good selling factor, and also it leads to a peaceful and healthy life, we can say. We also plotted this graph. This was basically average user sleep pattern. Now the sleep data set up to the minutes. And I just perform group by, so very similar to the per day data set, so I didn't much deep dive into it. Now we have the calories. The trend of average calories burned by the user all day. The percent of user who increased their calories burnt over 1 month. So we wanted to check if each user's average calories burnt in last week is higher than the first week. We wanted to see a month-wise distribution. And the percent of users who increased their calories burnt around 20%. The 1/5 of the users have increased their calories burnt. Okay, this looks good for us. I want to say that compare the first 7 days up to last 7 days. But this was this kind of graph comparison, like from the first 7 days of the data set to last seven. But we found that there was quite a drop in the last 7 days. So we just compared the first 7 days of data set to first 7 days of May. You'll see around 46% there was an increase. Okay. So there was 20%. This was due to abnormality. We find it here, like this drop. Okay, let me just speed up. Okay, now we have the intensity. This is also similar. We were looking for the three types: sedentary, medium, and active. We plotted it. We went for the minutes, all three labels, or versus date, average minutes versus date on all three labels, or legends, we can say. Now we have the steps, the average extent of total steps per day across all the users. Same, we found a decline, and we have the plot. And now we are comparing for each user the first week of dataset versus the first week of May. We are not going for the last few days. And 41% shows the increase, and the max increase was average daily steps was around 200%, approx around 2 times. But this could be a good selling point for our like billable team. So the final insights I could draw for our team, like one of the users lost around 1.7 kg in 1 month. So the billable can contact these users and make an interview and share his story to the target group. They can also plan for advertisement, like how billable can or has transformed his life. Okay, and one of the users sold around 2x, 1.96 times increase in average daily steps. We can plan the same with him. Also, average we could say we found that around 41.3% of the users using the device have shown increment in their average daily steps. This could be a good selling point for us. And 25% of the user 624 have shown great improvement in sleeping duration. And we see as we go, people like mature, they have more stress and they find it hard to sleep. So this could be a good selling point. And since a good sleep indicate a healthier or peaceful life, so yeah, this is definitely a good point. And around 46.67% of the users have shown increment in their average calorie burn. Okay, we got data from comparing the first week of data set to the first week of May. We can also use this. Basically, these are the selling points. We can make like videos, we can make interviews, we can show that from using labeled smart devices, people are transforming their lives. So definitely this would come and move towards a healthy and better life. Okay, so future works basically, the data set we have was only for a month. This was not enough. We should have at least, I should say, 3 to 6 months, because changing our health or bringing a major changes to our health need time. 1 month, uh, if you do some extreme workouts, yeah, you can see the results. But to see a long-lasting change, this would definitely a 3 months or 6 months up to data set. And we have missing data set for important factors like weight, which is a major source of attraction to our new customers. So we should be very careful. We should look for new data set for at least weight, because we can find some new insights. So definitely it could be a good selling point for us. We should try merging different data sets. We'll try to achieve this in sequence. Okay, thank you.